All right, welcome executives to today's explainer. For the next 10 minutes or so, I'm going to be stepping into the role of your lead sustainability consultant because, well, we've got an urgent operational briefing to get through. The whole landscape of plastic manufacturing is shifting literally right under our feet. What used to be just, an environmental talking point, it's now a massive, absolutely crucial vector for corporate risk and your return on investment. So today, we're going to unpack some cutting-edge research mapping out the future of polymer modification and circular plastics. The ultimate goal here? To show you exactly how to future-proof your supply chains. Let's get into it. I want you to think about this number for a second. 400 million. We are producing 400 million tons of plastic globally every single year. Sure, we've spent decades perfecting the production side of things, but our end-of-life management for all this material is just totally broken. We're creating this massive, compounding environmental and financial liability year after year, and frankly, the bill for this take, make, dispose model is finally coming due. Okay, let's dive into this because this right here is the burning platform of our current operational reality. Of all those hundreds of millions of tons of waste generated back in 2022, 40% went straight into landfills. Just buried. Another 34% was incinerated. 17% was completely mismanaged and leaked right into the environment, which leaves 9%. Only 9% was actually recycled. Let that sink in. From a purely industrial perspective, that's just a catastrophic loss of valuable raw materials and a staggering operational inefficiency. So here is our executive briefing agenda for how we navigate our way out of this inefficiency. 1. The imminent economic risk. 2. Mechanical versus advanced recycling. 3. AI tools driving innovation. 4. Overcoming transition barriers. 5. The circular plastics roadmap. And finally, 6. Calculating circular ROI. I promise we're going to trace a very clear path from the threats you face today right to your hard ROI metrics and future profitability. All right, Section 1. The imminent economic risk, regulation, and carbon realities. Let's jump right in. As industry leaders, you absolutely must be aware that the regulatory landscape is moving fast, like incredibly fast. Over in Europe, the EU's packaging and packaging waste regulation mandates that by 2030, literally all packaging has to be designed to be reusable or recyclable. And here in the US, we're seeing surging state-level extended producer responsibility laws in places like Maine, Oregon, and California. They're basically shifting the financial burden of waste management directly onto your corporate ledgers. And then there's the carbon footprint. If we don't pivot, primary plastic production emissions are on track to hit 4.75 gigatons of CO2 equivalent by 2050. To put that into perspective, that could eat up to 31% of the remaining global carbon budget for keeping warming below 1.5 degrees. The carbon penalties alone are going to make traditional operations economically doomed. Okay, Section 2, mechanical versus advanced recycling, the technology shift. Time to evaluate our lifelines. And this brilliantly illustrates the core of the problem. Historically, we've just relied on legacy mechanical recycling, right? Shredding and melting. But every single time we do that, we subject the polymer's molecular chains to immense heat and stress. The chains break down, they get brittle. Because of that degradation, mechanical recycling maxes out at roughly 31% efficiency, and it mostly just leads to lower quality downcycling. But the innovation here, the future, is advanced chemical recycling, specifically catalytic depolymerization. This method uses catalysts to chemically reverse the damage under mild conditions, letting us recover virgin quality monomers. It basically enables infinite closed-loop cycles without any performance loss, a real game changer. Now, you might be wondering, what about the really dirty or highly complex waste streams like electronic shredder residue, for example? Well, that is exactly where solvent-based physical recycling comes in. By using specific solvents based on their solubility parameters, we can selectively dissolve the polymers we want, completely leaving behind the metals, the flame retardants, and all those other impurities. Then, we use an anti-solvent to basically precipitate that pure plastic right back out. It's a fantastic process that strips out contaminants and recovers high-purity polymers without ever degrading the actual chemical bonds. Moving on to Section 3, AI tools driving innovation, optimizing operations. Look, AI is definitely not just a buzzword anymore. It's a literal cost saver on the factory floor. Machine vision models like Mask RCNN are hitting over 91.2% classification accuracy and real-time industrial sorting. And it gets even more impressive in the lab. Researchers are using graph neural networks to discover brand new ionic liquid catalysts for breaking down PET plastics, identifying options that are 29% cheaper and produce way fewer emissions than the current benchmarks. Plus, deep reinforcement learning is out there actively optimizing flow chemistry. It's cutting all that manual, trial and error experimental R&D work by 50 to 75%. This is exactly how you optimize your margins. All right, section 4, overcoming transition barriers, lab to industry. So scaling is hard. There's no way around it. We are facing some very stark financial and infrastructural barriers here. For one, chemical recycling plants require a massive amount of upfront capital intensity. And then you're dealing with incredibly unpredictable and highly variable waste feedstocks, because real-world trash is messy, right? On top of that, the specialized dynamic catalysts required for these reactions are still pretty expensive right now. And crucially, there's a real lack of standardized life cycle assessment and techno-economic analysis data. It's tough to justify a huge investment to your board if you can't confidently project the exact payoff. But look, pragmatically speaking, these are transitional challenges, and they're actively being solved. Now, what's really interesting about this slide is that it shows how advancing these technologies isn't just about the chemistry itself. We need a totally multidisciplinary approach. We have to surround that core science with comprehensive life cycle assessments and actually integrate machine learning to dynamically optimize everything. This kind of holistic, interconnected ecosystem is exactly what's required to confidently take these solutions from the lab bench to full commercial scale. Which brings us to Section 5, the Circular Plastics Roadmap, a phased strategy. We highly recommend a clear, 3-step phased adoption strategy for your corporate roadmaps. First up, adopt design for deconstruction at the very beginning of your early product R&D. Stop building products that are literally impossible to take apart. Step 2, integrate smart materials like vitrimmers and dynamic covalent bonds into your material streams so you can abandon those unrecyclable traditional thermosets. And step 3, work toward deploying AI-assisted closed-loop catalytic reprocessing at scale to infinitely reuse your raw materials. Let's actually double-click on that second point for a moment, because you really need to know about this materials science breakthrough, vitrimmers. Traditionally, you had to choose between the extreme, unyielding strength of a thermoset. Think about the epoxy in a circuit board, which you basically can never melt down, and the weak recyclability of a thermoplastic. While vitrimmers completely eliminate that compromise. They're smart, self-healing polymer networks that utilize dynamic covalent bonds. At room temperature, they are every bit as strong as a conventional thermoset, but apply heat and those bonds dynamically swap around. The material can flow, heal itself, and be completely reshaped and reprocessed. It's incredible. Let's move to and see how this builds into a unified future architecture for the circular plastics economy. It bridges pure catalytic recycling innovation with AI optimization and rigorous life cycle analysis. This whole shebang is the exact blueprint you need for aligning your corporate policy with cutting-edge science to guarantee your long-term resilience. And finally, Section 6, calculating your circular ROI. The bottom line. Let's talk numbers. So, the crucial point is this specific number, 1.52. Research shows that while it's definitely more capital intensive to set up initially, mechanical recycling achieves a long-term benefit cost ratio of 1.52. That means for every single dollar you invest over the life cycle, you're seeing $1.52 in return. That factors in the sales of recovered materials and the massive avoided costs of landfilling or incineration. It's just mathematically superior to throwing materials away. And advanced chemical recycling is really proving its worth on the commodities market too. Let's contrast the economics. A virgin, fossil-derived ethylene might have a minimum selling price of around 61 cents per kilogram. But the high-purity ethylene generated from catalytic fast pyrolysis, that commands a minimum selling price of 85 cents per kilogram. That's a 1.4x premium. Sure, the capital investment is high, but you're generating a high-value, premium product that the global market is desperately demanding right now. And the global policy landscape is moving super rapidly to back up this math. Look at this quote from a recent comprehensive analysis. By requiring 40% recycled content, investing in waste management, countries could cut mismanaged waste by 91% and reduce emissions by 1/3. We are looking at a $50 billion global investment wave coming into waste management. The early corporate adopters who prep their infrastructure for this transition are for sure going to capture the lion's share of that upside. Which leaves us with the ultimate strategic decision for your boardroom. This whole shift, it isn't just about environmentalism anymore. It's about operational survival and capturing future market share. The tools are ready, from AI-optimized catalysts to vitrimers. So I'll leave you with this. Will you cling to the fading economics and mounting liabilities of traditional plastics, or will you step up and lead your industry's circular innovation? Thank you so much for joining me on this explainer, and I look forward to helping you build that future.